Alright, video 3.2, the multiplier. Now we multiply. Alright, so this is an odd term that, I don't know, it always, maybe because it's so wordy, it seems to always throw people, don't let it. Autonomous change in aggregate spending. And we're going to abbreviate that as LAAS. Autonomous change. So this is the change in spending that causes the series of spending changes. So it's the first domino to fall, and that's why I put that picture there. So it's the initial change. So it is the government spending $100. That could be the autonomous change. It could be you getting a $100 raise. It doesn't matter, and we're not really going to focus on what that is. The point is that it is simply the first change in spending. So it's abbreviated as LAAS. All right, so what is the multiplier? It is the ratio of change in real GDP caused by a change in the autonomous aggregate spending. Okay, so again, this just kind of gives you a nice mental image or visual of what this multiplier looks like. A person buys, or they get a job, so they get paid, make commission, they go and buy something at a store. That guy then goes and he sells something to somebody else. Now he has money and he goes and buys something, and it's just this cycle. So we're looking at from the initial change, because remember, like the first video laid out, that initial change in $100, it has more than a $100 effect on the economy. So we're looking at what is that. So that's what the multiplier tells us. So our multiplier equation is 1 over, and there's two ways to do this, either 1 minus the MPC, or more directly, it's the same exact thing, 1 over the MPS. So it's pretty simple, 1 over the MPS. Again, like I said in the previous video, video number 4, 3.4, is going to have all of these. We're going to practice the math. At the moment, if you remember from the previous video, my example was that the MPC was 0.8, which means by definition the MPS must be 0.2 because they equal 1. So 1 minus 0.8 equals 0.2. So if that is our MPS, we do 1 over 0.2, and that is going to equal 5. And so our multiplier will equal 5. Alright, we have another thing that's involved with these. This is, again, we're kind of just exploring the beginnings of this. We're going to do the math in video 3.4. We also have an equation called the consumption function, and this shows the relationship between consumption and current disposable income. So, if your current disposable income is $1,000, how much of it are you consuming? And so what we're trying to do is figure out how much, if we want to know if your disposable income were to change, how much would you then consume? How much more if it were to increase? How much less if it were to decrease? So the consumption function allows us to do just that. And here it is for you mathematically. I have it in lowercase letters here, so this is an individual's consumption function. If we do it in all caps, then it would be macro. It would be an economy's consumption function. So we have C equals A plus the MPC times disposable income. So we have to remember what all of our variables are here. We have C is consumption. I think on the next slide I'm going to tell you what A is, so I'm going to skip that one. MPC, our marginal propensity to consume, and our disposable income. And at the bottom I just have a reminder for you of what disposable income is. YD equals income plus transfers minus taxes. Here's A, autonomous consumer spending. This is the amount that a household spends if they have no disposable income. And I know that that's a weird sounding concept. This slide kind of gives it away to you how that would be possible. A lot of times people are thrown, how can you spend money if you don't have any disposable income? Well, this is what happens when people lose jobs. If you lose your job, you still have bills to pay. You still have a rent, you still have, whatever bills you have, electric bill, food. The way you pay for that is either hopefully it's through savings, and if not, it's through credit cards. But either way, we are going to spend money even when we don't have disposable income. And the letter A is going to represent that. So in our equation, C equals A plus MPC times YD. A is how much we spend even without any disposable income. And so here you have the macro version, C equals A plus MPC. This is the aggregate consumption function. Remember that word aggregate, we're talking about the economy now as a whole. So you have our consumption function there for you, and this is how you're going to graph it as well. We'll worry about that more, actually I think the next slide, but this is what you do. So have fun with this one. Your y-axis is C, consumption. Your x-axis is income, or y. So that's fun. And then you have your intercept. The intercept is going to be at A. So it's the point where, sorry, just like looked away, got distracted. It's the point where you're spending money even with no disposable income. So you notice how they don't meet. You'd have some consumption even with zero disposable income. And then as your disposable income increases, you increase your consumption as well. So the slope, to find the slope, it is just your MPC. So 0.8, 4/5, or something like that. But you see that it's positively sloping. All right. Oh, that's it. This has been a Money production. You go to Taco Bell, Gretchen Wieners.